A universe in crisis. How the James Webb Telescope is challenging the foundations of modern cosmology. I've spent my whole life developing a particular theory of the universe, and now that theory is being challenged. I welcome that because that's how we move forward. That's how we make progress in science. Professor Carlos Frank, Durham University. Humanity has always looked to the stars for answers. For centuries, we believed the heavens were unchanging. Then came telescopes, satellites, and space-based observatories, each step expanding our understanding, yet also exposing new mysteries. Now, one telescope is shaking the very core of our understanding of the universe. The James Webb Space Telescope, JWST, hailed as the successor to Hubble, is not just looking deeper into space, it's looking back in time, to an era just a few 100 million years after the Big Bang. But instead of confirming our best theories, Webb is challenging them, and with each new observation, it threatens to redefine the very foundations of cosmology. The unraveling of a century-old worldview. When JWST launched in December 2021 and began collecting data in mid-2022, scientists around the globe waited in breathless anticipation. Many expected that Webb would show us the universe's first light, the earliest stars and galaxies forming out of the primordial gas. Instead, it found mature, massive galaxies far earlier than theory allowed. Some galaxies appeared too large, too evolved, and too structured to have formed so soon after the Big Bang. This paradox has been dubbed the impossible galaxy problem. The telescope that was supposed to show us the first stars of the universe is becoming a killer of the previous worldview. Professor Frank. These findings are not isolated. A growing body of JWST images reveal anomalies that cosmologists cannot explain within the framework of the Standard Model of Cosmology, a model based on the Big Bang, cosmic inflation, and an expanding universe powered by dark energy. The CMB, our window into the young universe. Until recently, the cosmic microwave background, CMB, was regarded as the oldest and most reliable fingerprint of the early universe. Discovered in 1964 by Arno Penzias and Robert Wilson, who later won the Nobel Prize, the CMB is the faint afterglow of the Big Bang, formed around 380,000 years after the universe began. It has long served as the foundation of modern cosmology. Tiny fluctuations in this background radiation offered clues about the density, composition, and expansion rate of the universe. Combined with observations from Type Ia supernovae, this data helped refine our measurements of the Hubble constant, which quantifies the universe's rate of expansion. But here's the problem. Different methods yield conflicting values. CMB data, e.g., from the Planck satellite, suggests a Hubble constant of 67 km/s/MPC. Supernova-based measurements give a value of 74 km/s/MPC. This contradiction is known as the Hubble tension or S8 tension, and it has rocked astrophysics for decades. What was once thought to be a minor discrepancy is now considered a fundamental crisis. And the James Webb Space Telescope is making it worse, or better, depending on your perspective. Webb's findings, revelations, and repercussions. JWST's ultra-deep field images show fully formed galaxies just 300 to 400 million years after the Big Bang, a time when, according to current models, such galaxies shouldn't exist. These galaxies are dense, complex, and rich in heavy elements, suggesting a far more accelerated process of galaxy formation than we previously thought possible. In other words, the universe may have matured faster, expanded differently, or formed under conditions completely unlike what we assumed. This opens up three possibilities. Our models of cosmic expansion are incomplete or incorrect. The Big Bang, as currently conceived, may not have happened in the way we imagine. There may be entirely new physical laws at play. We see in Webb's images evidence of a universe that is very different from what we have long thought. Anonymous astrophysicist. Do we know anything at all? The nature of scientific knowledge. The crisis now unfolding forces us to ask a humbling question. How much do we really know about the universe? Scientific knowledge is built on a framework of empirical observations, mathematical models, and logical inference. These models are called theories, but in science, that word doesn't mean guesswork. It means a framework supported by data and experimentation. But no theory is sacred. All are subject to change when new evidence emerges. This is the power and vulnerability of science. It is self-correcting. Even cornerstones of modern physics, like Newton's laws of motion and Einstein's theories of relativity, have limits. Newtonian physics works well on human scales but breaks down at the quantum level and in the presence of extreme gravity. Einstein's relativity explains space-time and gravity elegantly, but it cannot account for quantum mechanics or fully reconcile the presence of dark matter and dark energy. The invisible universe, dark matter and dark energy. Modern cosmology assumes that 95% of the universe is made of substances we cannot observe directly. Dark matter, mysterious mass that does not emit or absorb light, but seems to exert gravitational influence. Dark energy, a repulsive force driving the accelerating expansion of the universe. Neither has ever been directly detected. Their existence is inferred solely from gravitational effects and redshift measurements. If these effects are being misinterpreted, or if alternative explanations exist, we could be building our entire cosmology on assumptions that will one day be disproven. Some scientists now argue that dark matter and dark energy might be artifacts of flawed models, or even products of unknown physics. Others hypothesize that their properties may have changed over cosmic time, or that they're linked to forms of information, fields, or intelligence we do not yet comprehend. A universe without a beginning? One of the most radical possibilities now on the table is that the Big Bang itself may be incorrect, or at least not the full story. If galaxies like those seen by JWST truly predate the time when structure was expected to form, this suggests the universe might not have originated from a singular explosive event. Alternative theories such as cyclic universes, eternal inflation, or even the steady-state model, which was long considered obsolete, are being reconsidered. Another area under scrutiny is the interpretation of redshift, the stretching of light as objects move away. For decades, astronomers have used redshift to measure distance and velocity. But what if redshift doesn't only result from expansion? What if other unknown phenomena are affecting light across cosmic distances? The future of cosmology, crisis or revolution? Today, science stands at a crossroads. On one hand, the James Webb Space Telescope is providing unprecedented clarity. On the other hand, it's throwing our most cherished theories into chaos. We must ask difficult questions. Is gravity fully understood, or is it just an approximation? Are constants like the speed of light and gravitational strength truly constant? Have we been interpreting the oldest light in the universe incorrectly? Could we be staring at the face of an entirely new physics? Some scientists respond with fear. Others, like Carlos Frank, respond with courage. For it is in the face of contradiction that science shines brightest. Final thoughts. The spirit of discovery. The most important thing is never to stop searching and exploring. Albert Einstein. The James Webb Space Telescope is not just a machine. It is a mirror, reflecting our ambition, our intellect, and our humility. It reminds us that truth is not fixed. It evolves. And so must we. It is no tragedy for old theories to be challenged. It is the sign of a living science, one that adapts, corrects, and grows. In every shattered model lies the potential for a new era of understanding, one that may redefine what we know about the origin, fate, and nature of the cosmos. Satellites subscribe to the journey. The future of astronomy is uncertain, but thrilling. Stay connected, stay curious, and never stop asking. What else is out there?